In this video, I'm going to be explaining how to solve a system of linear equations. That's just a fancy way of saying, let's find the intersection point between two or more lines. In this video, we're just going to find the intersection point between two lines. So if we're finding the intersection between lines, and parallel lines never intersect, then if we happen to get a solution that is not equal, or we can't solve it, we are dealing with parallel lines. Parallel lines will never intersect, so if I'm trying to find the intersection point between them, I will have no solution. You could also compare the slopes of those two lines if it's ever in question. If you get equal slopes, you know they're parallel, and they will never intersect. Therefore, we will never have a solution to their system. Lots of different methods to solve systems. We're just going to talk about two today, just the graphing method and the elimination method, which is sometimes called the combination method. So the first method, to graph it, is just a visual way of solving these systems. To graph a line, you may want to put it into slope-intercept form. So line 2 is already there. We could start at positive 4 on the y-axis and use our slope down 5 over 4 to get our other points and draw our line. Line 1 is not in slope-intercept form, so we could solve for y to put it in slope-intercept form, and then we could graph it. So subtract 8 from both sides first, and then divide everything by 4, and we end up with our equation y equals 1/4 x minus 2. So we're going to start at negative 2 on the y-axis and use our slope up 1, right 4 to get other points on our line and draw the line. So after we've drawn both lines, we can see that they intersect or cross at a single point. That is called the solution to the system. So they intersect at 4, negative 1. If you check both of these answers, you could plug x equals 4, and you could plug in y for negative 1, and we should get equivalent expressions here. You can do the same thing with line 2. Plug in 4 for x and negative 1 for y, and it should be a true statement. So one more time. This time we're dealing with two lines that are both not in slope-intercept form, so let's put them in slope-intercept form. I'm going to do my work for line 1 over here. So we need to subtract 6x or move 6x to the other side. Now we have 3y equals negative 6x plus 24. To get y by itself, we divide everything by 3. So negative 6 divided by 3 is negative 2. And 24 divided by 3 is positive 8. So now we can plot that starting with 8 on the y-axis and using our slope of negative 2, right 1 to get other points. Draw that line. To work on line 2, we need to move 8x over to the other side, so subtract 8x from both sides. Now we have negative 6y equals negative 8x plus 12. Divide everything by negative 6. Negative 8 divided by negative 6, that's a negative divided by a negative, which simplifies to a positive, and we can reduce 8/6 by dividing top and bottom by 2 to get 4/3. And then our y-intercept is 12 divided by negative 6, which is negative 2. So start at negative 2 on the y-axis and use your slope of up 4, right 3 to get your other points on the line and draw your line. Since we plotted both lines, we're looking for the intersection point. It happens at the location 3, 2. So there's the solution to our system. Oftentimes, graphing is not the best way. Sometimes you're given numbers that fall outside of a 10 by 10 grid. Other times when you're doing applications of systems, you're dealing with large amounts of money or large populations, in which case graphing is not necessarily the easiest way. So we need some algebraic methods. There are many other algebraic methods to do this. I'm just going to focus on the elimination method in this video. The idea behind the elimination method is that we're trying to cancel one of our variables. We don't know how to solve two variable equations, but if we can eliminate one of those variables, then we could solve a one variable equation. So we're trying to cancel either x or y, and you always have your choice. So looking at these two equations, if I was to try and cancel my y's, I would need opposites. Since this is negative 6y and this is positive y, if I could get this to positive 6y, then when I combine my equations, I can cancel those y's. So the easiest step would be to multiply this first equation by 6. And that means we got to multiply everything by 6. So if I multiply each of those terms by 6, 6 times negative 6x is negative 36x. 6 times positive 1y is positive 6y. And 6 times negative 21 is the same as negative 20 times 6 plus negative 6 times 1. So negative 126. So rewrite that second equation right underneath it. And we're going to line up all of our terms with like terms. So x's on top of x's, y's on top of y's, and numbers on top of numbers. And then we're going to combine, which means add. So negative 36x and positive 8 combine to give us negative 28x. Positive 6y and negative 6y cancel. That's what we wanted to happen. And negative 126 and positive 14 combine to make negative 112. So now that we have one variable, we can solve for it. To solve this, we're going to divide both sides by negative 28, and we get x is 4. So we canceled our y variables. We solved for x. The third step is to substitute this variable back into one of the original equations. It doesn't matter which one, you have your choice, whichever one seems easier to evaluate. I chose the top equation, but we could have substituted it in the bottom just the same. So I'm plugging 4 in for x. So rather than negative 6x, I have negative 6 times 4. Rewrite the rest, plus y equals negative 21. Simplify, negative 6 times 4 is negative 24. And to solve for y, we're going to add 24 to both sides and get y equals 3. So now that we have both of our variables for a coordinate, we can put it in coordinate pair form and state the intersection point, which is the solution to the system. So let's try another one with elimination. This time we're given these two equations. I could cancel my x's if I could create a negative 10 down here. So if I could multiply everything by 2, I could cancel my x's. We could also cancel our y's. Maybe we choose to cancel our y's. So in order to cancel a negative 4y, I would need this to be positive 4y. So I would need to multiply by negative 4 to make it positive 4y. So we can multiply everything on the top equation by negative 4. I chose to cancel the x's just because it's multiplying by a little smaller number. So I'm going to multiply everything in this bottom equation, or line 2, by positive 2, doubling every term. So I get negative 10x minus 8y equals negative 46. Let's stack our two equations. Here was the original line 1 and our new line 2, stacking x's on top of x's, y's on top of y's, and numbers on top of numbers. Combining these two equations, or adding them, we cancel our x's. That's what we wanted. Negative y minus 8y gives us a negative 9y, and negative 17 minus 46, or plus negative 46, gives us negative 63. And solve for y by dividing both sides by negative 9. We get our y solution is 7. So now that we know that y is 7, I'm going to pick which original equation I want to plug it into. I chose the top one because I didn't have to multiply when I substituted. So rather than 10x minus y, we got 10x minus 7 equals negative 17. I'm going to add 7 to both sides. That gives us 10x equals negative 10. I'm going to divide both sides by 10, which gives me my x solution of negative 1. So now I got my x and my y coordinates. That's a coordinate pair. Make sure you state your coordinate in alphabetical order, x, then y first. And that's the solution to this system. And again, you can always check. You can plug your solutions back into either equation. You want to check both of them. And if we get true statements, then we know that our answer is correct. We can also maybe use a graphing utility, and we could graph these to verify as well. So there's an introduction to solving systems of linear equations, or more simply, just finding the intersection point between the lines.